We'll practice using conservation of energy to solve projectile motion problems. Here's the problem. A 0.50 kilogram ball is thrown straight up at 12 meters per second. Ignore air resistance. Part A, use conservation of energy to find the maximum height. Part B, find the ball's speed when it is 3.0 meters above the launch point. First, let's find the maximum height. At the top, all kinetic energy is converted to gravitational potential energy. We set the initial kinetic energy equal to the gravitational potential energy at the top. Cancel mass m and solve for h. H equals v squared over 2g, which is 12 squared over 2 times 9.8, equals 144 over 19.6, equals 7.3 meters. Now find the speed at 3.0 meters. Use energy conservation between launch and that height. The kinetic energy at that height equals the initial kinetic energy minus the gravitational potential energy gained. Cancel m and solve for v prime squared. V prime squared equals v squared minus 2gh prime, which is 144 minus 2 times 9.8 times 3.0 equals 144 minus 58.8 equals 85.2. V prime equals the square root of 85.2, which is 9.2 meters per second. Remember, in the absence of non-conservative forces, total mechanical energy is conserved. You can equate initial and final energies to solve for unknowns.